Okay, flat earthers, here we go again. So I'm getting responses to my other videos. I'm getting flat earthers that are trying to engage me, um, and they're failing, but I'm enjoying this. So, stupid flat earthers, here's the problem. Your stupid comment is that you can't have pressure next to a vacuum. And my response is no, duh. I mean, you can't have pressure, a pressurized volume right next to a vacuum. I mean, unless it's surrounded by some kind of magnetic field or something. You could have like a magnetic field surrounding a pressurized volume or a vacuum, right? But that's not the issue here. The issue here is the Earth's atmosphere and space. And what the flat Earth stupidity does is says, oh, hey, you got the atmosphere and it's got all this pressure and then there's this big drop off, right? So I'm going to draw the line, emphasize the drop off, because that's really the flat Earth stupidity. Is it? Oh, look, there's this drop off right here. So there's pressure, and then they're accusing us of saying that there's vacuum next to pressure, like the pressure is like 1 atmosphere, or so many bars, or so many torr, or whatever they want to call it. And then there's this drop off. It just boom. No, that's not reality, guys. Flat earthers, stop lying. What happens is you're at sea level, and as you gradually increase from sea level to space, you have a gradual decrease of pressure until at some point, you call it a vacuum. Because what is a vacuum? A vacuum is merely a lack of particles in a volume. So here, there are essentially no particles, right? You can just say there's no particles in this volume here. And as you continue closer and closer towards the Earth, as you're getting closer and closer towards the Earth, you get a few particles and a few more, a few more, a few more as you're getting closer and closer to Earth. Right here is, you're at Mount Everest and you're getting closer and closer and closer, going down Mount Everest, for instance. And then you end up at sea level where there's enough particles and you're breathing. So flat earthers, you go all the way up here, you're vacuum, right? No particles, no atoms floating around in that area that you're in. As you get to a particular, I guess, altitude or distance to the Earth, you will designate a certain amount of particles per volume to be not a vacuum anymore. But that distinction is at that point arbitrary. Some people can say it's 1 particle per cubic centimeter, or 10 particles per cubic centimeter, or 1,000 particles per cubic centimeter, or 1,000,000 particles per cubic centimeter, whatever it is. But by the time you get to Earth, the sea level, you're dealing with billions of particles per cubic meter. 1 atmosphere is, I think, the equivalent of something like 30 trillion particles per cubic centimeter or per cubic meter, or whatever it is. Doesn't matter what the actual numbers are, because it's all a matter of gradation. And I don't need to sit up here and quantify gradation to such a precision. I just need to make the general point that, hey, you get to a certain point above the atmosphere, the higher you go, the less dense the air is. And that is far different than this flat Earth stupidity up here, which is, oh, you got pressure next to, the key stupidity is next to a vacuum. And that's not what is taught by mainstream science when it comes to the atmospheric pressure of Earth. Okay, I'm done.